So it appears that models are doing what both me and Larry Cosgrove said. They are starting to trend colder, and their solution is becoming more snowier, more frozen precipitation in other areas. Obviously, I don't think temperatures as high as 50-something degrees is going to be that sustainable, even with a lakes cutter, which is, I do believe that the storm could exit anywhere between the eastern Great Lakes and southeastern New Jersey. But I think all rain scenario has been pretty much pulled off the tables. It's very important to use models in their primary resolution range. And NAM model was the very first one to really start to catch on to these changes. And being that the NAM has been doing very good these past storms, in its range, guys, if you start to use the NAM model outside of its range, it's not going to end up verifying. Understand that, okay? But we're getting close to the NAM's primary range. It is also good to use during storms, but, it really depends on the situation. So what we're going to do right now, and I know the European model shows that big blizzard for New York City, New England. I'm not going to get into that. That's still far away, but me and Larry Cosgrove are very interested in that. But let's first go over our teleconnections real quick. Remember what I told you guys before. Teleconnections are not a set done deal. Weather alters teleconnections, not the other way around. So our AO is going to go down and then squiggly. Yes, because there's teleconnections. See all these black lines? If this was right, these black lines would be like this, which is not. It's not right, okay? Things change teleconnections. Here's what we know right now, okay? We're going to have a spike over here, okay? Our teleconnections are going to spike up with our Arctic oscillation. That is what we know. Now, our NA up. If you look over here, all of a sudden now, it's trying to head negative in the long, long range. This is why I don't look past a certain point with these. NAO comes up a little bit. Okay. Same thing. PNA. Okay. PNA is supposed to tank. Bam, like that. But if you guys didn't realize before, now all of a sudden, instead of just being a straight shot down, there's a kink up here, all out of nowhere. You see, this is inconsistency. So up to this point, we know it's going to get to neutral. I can't say negative yet, but boom, like that. Okay, our next support system, Madden-Julian oscillation. Go over to that. Now, you see, we're still in the circle of death. I'm not looking past this point over here. Okay? None of them actually are even going into 3. None of them. They're going into 2. But that's going to change, of course. We're not looking past this point. Circle of death and no influence. Okay, let's go over to our models now. We're going to start off with a GFS model. So the GFS model, which is starting to do bad again, of course, even with its upgrade. People glorify it should stop. Watch this right here, okay? You have a storm developing down over there. Here's our southeast ridge, well, yeah, east coast ridge, right? Where it pumps up like this. But this is what also intrigues me. Look where it's going. It's starting to pull away. Now, all of a sudden, this is pulling away. This storm's going up like this. But one thing that is telling me that this storm might get shifted further east is this is pulling away. Do you see this right here? If this was a storm that was cutting up like this and the precipitation breaking out like that, I would say colder damming, but obviously there's no precipitation in this area. You can see that these lines are kind of bending out. This is cold air pressing like that. That means that this storm could shift further east or further southeast, which I'm keeping an eye on. So, if we go and monitor what's going on over here, it still is pushing to 1048 millibars. 1048 millibars. And it's still pushing and still pushing. You have all this precipitation breaking out over here. Comes it up there now. And it's pulling away. And it's pushing Arctic air in. If you look over here, southeast ridge is pulling away. So, the GFS literally takes the storm here and teleports it here. So the GFS is not really handling the storm that well. I don't think it will. It's dealing with a storm that is clearly not northern energy. It's going to be starting down here. So if you look, you got the storm down over here, high pressure drilling like this. So either it's going to go like this, or once it gets to the Tennessee Valley, maybe it can do something like that. Though I think the coastal idea is pretty much not going to happen. I don't see the real support for that. But, you know, it's always possible. You can never discredit everything. But, yeah. So, we go back over here for a second. Now we're going over to our 500 millibar chart. What's very interesting is over here, as the steering winds, once they get up, it's funny because the winds up here are a little bit more amplified. So, you know, if the storm's forming down over here, it's going to follow the most amplified wind, which would go up like this. Here's the only little issue. You see how flat the winds are over here? Now the winds are starting to flatten out over here. And now they're just starting to flatten out in this area. This tells me the storm has a possibility to kind of come more south and east. So we're going to monitor that. Okay, next things next. I'm not clicking on the URL because we're not looking at that storm. Canadian is the very first one to finally catch on to my thinking. This is not an all snow event. I don't see that happening. But if we go back, watch. Storm development. Okay. And the high pressure is also weaker as well. Weaker high pressure system. Storm is cutting through. Again, cold air is being pressed from high pressure, just not as amplified as it goes down here. But look how much more snowier this is. That's because this high pressure weakens and squeaks out like this. And the precipitation storm is starting to get pressured on by this high pressure over here. Okay, 1040 millibar high, 1038, 1034. So that pressure is pushing. You know, using these lines of pressure can really help you when it comes to forecasting. And I've never really seen people use it do that before. I think I'm the only person that I know at least that does that. So here it goes, and it's still snowing now. It's still snowing. So now we're going over to heavy rain up in New England, moderate rain over here. The storm's pulling away, cold is rushing out over here. You know, this is very, very, very close to being all snow scenario. It really, really, really is. Because it's not so much the storm track exactly, only a little bit of a deviation from cutting through here. But the high pressure is pulling away more. So that's basically what the Canadian's catching on to. Okay? So, if we go back over here, the storm's breaking out. Upward dynamic chart. Look over here. Storm's down in this area right over here. Steering winds. And the same thing. Your steering wind brick wall rarely starts to form right in southern New England. Southern New England, central New England, northern New England. And this is all brick wall stuff right here. This whole thing's like a brick wall. So this storm only this is going to guide it more like that. Now, if these kinks, these winds, these flatten out over here, then the storm goes more southeast. So I'm keeping an eye on that. That's why it's telling me the most southern point that this storm can go is like this. On the Canadian. The most north it can go is into this part of Canada. But I think it's going to kind of cut through like that. So that's what the Canadian's showing right now. And the NAM model right now is actually getting very close to its range. And it's been performing very well in its range. It really has. Once you start to use it outside of its range, it just falls apart. But same thing. The NAM is starting to kind of get on what the Canadian was trying to do before. Storm comes up. High pressures over there. Now it's pushing over here. Keep in mind also, okay, the placement of the high pressure is also important. Because if the high pressure is up over here, then it pumps warm air, but it's not as warm as, say, air down over here. So the high pressure is more northward, and that effect is not being felt points west. So it's a little bit further northward. But look, watch what happens. Watch it. It just... Look, you see? See how low pressure is coming up through over here? High pressure is still there, but this is just going to show you how strong the cold air is going to be coming down with this system. But look, if you have a high pressure over here, you're pumping air, like, you know, warmer over here. It's not that warm. It's not like southeast ridge, you're pumping 80-something temperatures, turns into 50. It's not as amplified. Okay? And you can clearly see that this high pressure system starts to pull away. And the snow is breaking out over here. And right over my house, I go over to mix. And I end as a mix, maybe in as snow flurries. I think the models honestly are going to trend colder. I really do. If it doesn't, it doesn't. Oh well. But that's just how I see it. So if we go over to our 500 millibar chart, same thing. Here's what's telling them. Storm is up in this area over here, and look how less amplified the winds are to drag me all the way up here. This is telling me that the storm has potential, okay, of doing something like this. That's right. Or doing something like this. So we have to monitor this situation and see how this evolves. A lot of people talk about the European model in the storm and shows. I'm not going to look that far. But just use models in their range. Once that range is over, happened with the last storm. European pushed everything further south. The GFS pushed everything further south. Meanwhile, these two models kept on pushing everything further northeast with the precipitation field. And these models nailed it. Okay? So it's good to, you can't, you know, you could look at the GFS and the Euro and the Canadian after the storm starts, but understand that it's going to be a little bit lost. I'm not saying to throw out what it shows, discredit it, but, you know, I wouldn't make a revised snowfall map just because of what they show. They have to have support from the shorter range models. Otherwise, what these models can do is they can freeze on their last frame because outside of their resolution. And that's when the shorter range models take over. So this is my update video. I hope you guys watch it, learn a little bit about something, and we're going to see what goes on. Now, here is something that's very important. If this storm does indeed come in more south and east like this, there's a 60% chance it can become a 50-50 low. And that is when I'll talk about the possible New England, New York City, New Jersey blizzard. But right now, I'm not going to go into that.